So ratios, how many people have heard of ratios before? That's what we're going to talk about. Okay, can somebody give me an example? Some examples of ratio? Yes, sir.
3 girls to 1 guy.
Sure, 3 girls to 1 guy. Right. 3 to 1. Right. What other kind of ratios have you heard or seen? Only one person? Come on, no other? Okay.
3 over 5.
3 over 5? Okay, and it could describe your number of boys, girls, or it could be many different things. You're right. So write this down. Ratio. You can use ratio to compare 2 quantities. Actually, more than 2. Doesn't have to be just 2. 2 quantities of same kind. What I mean by same kind, that they have to have the same unit. Okay, so write this down. So we're going to start with that definition. Well, not definition. Description of ratios. Starting with this, that they have to be same kind. Okay, you can't compare, I don't know, distance to time. By the way, does anybody know what that's called? If I compare distance to time, for example, 25 miles per hour. That's a rate. That's exactly right. So, if we're comparing same type, same kind, which have same units, then we're talking about ratio. Okay. Good. So you've seen ratio, like ratio of 2 to 1, maybe I don't know, 2 iPhone versus 1 iPad or something. How many things got sold? I don't know. It could be that. It could be anything. Is there another way to represent a ratio 2 to 1, a different way, other than just writing 2 to 1? That's one of the most common way. But another way? Come on, some other person. This one, Victor is the only one that knows. Like, yeah, go ahead.
2 semicolon 1.
You could semicolon 1. Okay. Is it semicolon or colon? Colon, right? 2 dots. Colon. 2. Yeah, I know what you mean. Okay, 2 colon 1. Okay, anything else? Is there another way? Yeah, Eric? 2 over 1. You can actually write it as a fraction using fraction bar. 2 over 1. Are there any other way? Is that it? Let me see. Yeah, that's it. Okay, basically. Sometimes they have 2 divided by 1, but that's division. No. So fraction bar is the most commonly used. So either 2 to 1, just write it that way, or using this colon there and then 2 over 1. Okay. So I want to talk about some rules for writing ratios. When you write ratios, you need to make sure that, first of all, what do you think the first thing you have to be really careful of when you're writing ratios? For example, can I do 2 days to 1 hour? Is that a good ratio? And say the ratio is 2 to 1? No. Stefan, so what do you think we should be careful of? You must use the same unit is correct. So I'm going to write that as the first thing. You must write things in the same unit. Okay? Alright, so first, whenever you are using a ratio, must make sure that we have the same units. Because if somebody says, oh, some ratio is 2 to 1, but then it's like, days to weeks, right? It's very different. You shouldn't write it as 2 to 1, right? Because it sounds like it's wrong. Okay, then another thing is, what about, can I give you a ratio like 4 to 8? Is that a good way to represent ratio, 4 to 8? No. Sarah, what should I say? Instead of writing 4 to 8, something is 4 to 8, I should say 2 to 1. So guess what the second rule is? Whenever you're using a ratio,
1 to 2.
I mean 1 to 2. Oh yeah, 1 to 2. Is it 4 to 8? It will be 1 to 2. Is that same as 2 to 1? No. Actually, that's another rules that we have to make sure. So first of all, if it's 4 to 8, we have to then, whenever we talk, simplify. Sure. Always simplify. And is 2 to 1 same as 1 to 2? If I'm talking about a ratio to boys to girls, is 2 to 1 same as 1 to 2? No. So do you think the order is important when you're talking about ratios? Very much so. So write this down. order matters. That's the third rule. And fourth rule is, okay, no units in ratio. When we're talking about ratios, you do not put any units. Okay? So write that down. There are 4 rules that you should be aware of. You must have same units, and you need to always simplify. Order matters when we're talking about ratios. And no units. Any question in terms of why we need to simplify and why the order matters in terms of ratio? I think that's pretty straightforward, right? Or having the same unit. What about no units? Why do I write no units? How come when we were talking about ratios, I say no units? Why can't we have units? Like, I don't know, 3 hours to 4 hours. Why do we say 3 to 4? Why don't we just say 3 hours to 4 hours? Anybody? Gianni, any idea why? Why don't we just say 3 hours to 4 hours? Why do we? Takes too long, yeah, that's one of the. And also, because it actually has to do something with the second rule. You should always simplify, right? So, when you have 3 hours to 4 hours, what do you think happens? Yeah.
Don't the units cancel?
The units cancel out actually. So, so yeah, no units means because the units will cancel out, right? 3 hours to 4 hours, hours over hours. What's hours over hours? They cancel out, right? So it's like, units actually multiplies when you. Never mind. Okay, when you talk about areas, right? Why do we have like meters squared? It's because you multiply meters times meters, right? That's why units could get squared too. So when the unit, if you have the same unit over another same unit, then they cancel out. All right. So knowing what we should study here, express the ratio 3 to 8 in 2 different ways. Knowing what we just learned, can you then write the ratio 3 to 8 in 2 different ways? Pretty straightforward. Okay. So, who could give me the first one? Austin, give me one.
3 and then the colon 8.
Sure, 3 colon 8. That was one of them. What's another one, Ryan?
3 over 8.
3 over 8. Is this pretty straightforward? Okay, so that's pretty straightforward. So let's go to example 2. This was kind of just to. Okay, this one is a little bit more interesting than the other one. So now that we have these ratios, can you then write in simplest form? Which you should be doing, right? Anyway, you should always simplify, isn't that right? So if I have these ratios, A, B, C, 45x to 30x, 18ab squared over 14a squared b, and then 5 days to 18 hours. Go ahead. Give you some time. Can you write them in simplest form? Go ahead. Okay, so A, let's see. Rachel, what did your group say?
3x to 2x.
You guys come up with 3x to 2x? How did you do that, first of all? You had 45 over, this, by the way, did anybody find that it's best to write this as like fraction like that? 'Cause that's how we, and you're 3x, what did you say? What did you, 3x to 2x. How did you get 3x to 2x, Rachel? Sure, you could divide top and bottom by 15, correct? Because if you have a fraction, right, you could divide top and bottom by the same number. Is this the simplest way to write this? Is there another way? Is there a way to simplify this a little further? What's x over x, by the way, Eddie?
Just 3 over 2.
Yeah, it just actually becomes 3 over 2. Oops, I wrote 3 over 2x. 3 over 2, okay? So I think this is the simplest way. And I think, Rachel, maybe you didn't cancel out the x's because what if x is 0 or something, right? But from now on, don't worry about denominator going to 0 unless I tell you, okay? So x over x, okay, you don't have to worry about x being 0. We're going to have denominator not equal to 0. Unless we tell you otherwise. Okay, so here, as you can see, x over x is just 1, so you get 3 over 2. What about b? Who has b? How about, Melissa, what did you get? What's your group come with? 9b over 7a. How many people agree? Raise your hand. Did you all, okay? Out of you, 9b over 7a, that's correct. Viviana, what did you get for c? It doesn't work. Right, could I write 5 to 18? No. That would not be. How come we can't write it as 5 to 18? Yes.
Then convert the days to hours.
Yeah, we need to convert either days to hours or hours to days, whichever you like. Okay. So which is easier? Converting, because we have to have the same what class?
Minutes.
We have to have the same units. So you cannot write this as 5 to 18. Okay. So
125 to 18.
okay. So what should we do? How about who haven't I called today? How about Ethan? What should I do?
You multiply 24 times 5.
Sure, because in order to make 5 days into hours, you multiply 5 times 24, which would be hours. Would you not agree? Over 18. So hours. As you can see, what happens to the hours? They're gonna cancel out. The units cancel out. By the way, should I multiply 5 times 24, or do you think I should cross cancel before I multiply them? I should cross cancel, right? What goes into 18 and 24? 9? 3? 6. Okay, that's your GCF, right? Stefan, how many times does 6 go into 18? What about 24? Okay, what's the answer, class?
20 to 3.
Okay. So the ratio you should have gotten from 5 days to 18 hours is 20 to 3. If you write 5 to 18, that'll be wrong, right? Because that would not have the same unit. Okay. So there you go. Any question? We good? Easy?
Yep.
Yes? Okay, so I would like to talk about the most important thing you're going to learn today. All the other ones, stuff we talked about, they're kind of reviews and pretty simple. Like I said before, during second semester, you're going to have a bunch of word problems, right? Especially when you're dealing with word problems with ratios. This is a part where people mess up the most. Okay, so write this down. Please, this is the key point of the day. When you solve a word problem, you may need to express a ratio in a different form. If two numbers are in the ratio of 3 to 5, you can, and think about how we do this. Think about this for a second. So write this down. As you write this down, think about this. This is actually the most important thing you need from today's lesson for word problems. Okay. This is a part where people mess up the most on the test too. Let's write this down. When you solve a word problem, you may need to express a ratio in a different form. If two numbers are in the ratio of 3 to 5, you can. What sort of different form are we going to use? So let me give you time to write this down first, and let's think about this before we actually write it out. Oh, some of you have an idea already? Hold on. Okay, so look up when you're done writing this so we could talk about this. All right, a lot of you are done. Okay, so if I say the ratio of boys to girl in my class is 3 to 5, how many boys and girls are in my class? What's the total number of boys and girls? Anybody? If I say that the ratio of boys to girl in my class is 3 to 5, how many boys and girls do I have? Yes?
You have 3x and 5y.
No? Not 3x and 5y. What do you think?
You have 5 boys and girls total.
I have 5 boys and girls total?
No, you have 3x and 2y.
No. How many people think I have 8 students in my class? Boys and girls. How many people because I have 3 to 5, right? It's got to be 8. Is that necessarily true? No. Right? Because some people think that, oh, I have the ratio of the boys girls is 3 to 5. Some people think that I have 3 boys and 5 girls. Is that right? No. It could be 30 boys and 50 girls. It could be 3 million boys and 5 million girls. You don't know. So what's the answer to that? How many boys and girls do I have in my class? Yes, Aaron? 3x plus 5x. Where'd you get that from? Because you're right. So, you're right. Write this down. When we have a ratio of 3 to 5, if the two numbers are in the ratio of 3, you can use 3x to 5x. Well, it could be 3y to 5y. You have to have the same variable, right? Doesn't matter which one. I used x. 3x and 5x to represent them because 3x over 5x is 3 to 5. Why is this necessary? So think about that. That's the important thing. Why do we want to use it this way? 3x to 5x. Aaron. X's cancel out, and so why do we need x's if they're going to cancel out anyway? You know what I mean? If they're going to cancel out, isn't this just 3 to 5? Why do we need the x's there? Why do we need to multiply 3 and 5 both by x's? One person? I sort of gave you the example. Victor?
Isn't it because if you multiply a number by x and the other number by x, multiplying it by the same thing, so if you get the total, then you know you're multiplying the same thing, so you're going to get the other number as well.
Yeah. In other words, who wants to? Victor is saying it correctly. Anybody wants to add something to that or summarize what he's trying to say? If I keep the ratio as 3 to 5, 3x to 5x, the ratio will always remain as what? 3 to 5, right? And so why do we need x if it's always going to be 3 to 5? Hello? Anybody out there today? Leah, any idea? Why do we want to use 3 to 5x? 3x to 5x?
It's possible for the numbers, for the two numbers of say boys and girls to equal any numbers as long as they're in the ratio of 3 to 5.
Exactly. We're not talking about just having 8 kids, 8 students all the time, are we? Like I said before, it could be 30 boys to 50 girls, right? It could be 3,000 boys to 50, 3,000 to 5,000, right? It could be what, 6 to 10? We don't know which it is. Do you understand? We're not necessarily talking about total of 8 students here, right? So because there are other possibilities, we need to keep in mind that, as long as the ratio stays the same, right? There are other possibilities, so we have to multiply 3 to x and 5 to x, Right, does that make sense? Hello? Are we getting this, guys? All right, let's do an example. It'll, I think, make even more sense when we do that one. Okay. So here's a question. The ratio of boys to girls is 5 to 4. If the total number of students is 981, how many boys and girls are there? And in this case, it's really obvious that it's not like I have 5 boys and 4 girls. You see what I'm talking about? Because that will not add up to 981. You see what I mean? Do you see why we need to use, right, the x? Okay, go ahead, see if you could do this one. Write this down. How many are we going to use? Should we use 5-step plan to solve this? Yes, always. Okay, whenever we have word problem, we need 5-step plan. So write this down. And I'm going to give you a chance to look at it. Okay, go ahead. Everybody write this down. Give you time. Okay, first of all, I know that some of you are not done. That's okay. Let's declare our variable first. How many groups are done at least declaring their variables for boys and girls? Not done? With these yet? Okay. Let's start. Let's do this together. Jaemin, how many unknowns do we have? Because that's one of our step 1, right? As we're reading this, how many unknowns do we have in this problem? 2. What are the unknowns? Blake? Vlad? What are the unknowns? I'm sorry, I said Blake. Vlad. Keep saying Blake. Vlad? Number of boys and number of girls. That's correct. So, how should we declare our variable since we have two unknowns? Let's declare our variable for the number of boys and number of girls. Who could help me how to do that? Austin? Let
X equals the number of boys and girls.
you can't do x for number of boys and girls. That means that the number of boys and girls are the same.
Okay,
So the ratio though is 5 to 4. So that's gonna help us. What do you need? So what do you think? No. Anybody in the group can help? Paul, what do you think? Oh, well, I want you to answer, Paul. What do you think? Well, you're supposed to have talk, right, along with your groups. If one of the person in the group knows, then everyone in the group should know too. No? Oh, okay. Let me give you some time then. Go ahead. Everybody talk. Okay, see if you can figure this out. I'll give you about 30 seconds. Go ahead. I want everyone in the groups to understand this part. This is important. This is one of the important parts. All right. 10 more seconds. Well, 10 seconds more. All right, stop. Okay, let's see. Hey, William, what did your group come up with? What did you guys say? Yeah, your group was really quiet, so I was kind of wondering what you talked about. What did you guys come up with? Say it again. Oh, that's the equation. So let's declare a variable. I think you got the right equation. What's the how do we declare the variables for this one? William? Let what? What is the number of boys? Because that's what we want to figure out, and number of girls, right? Those are two unknowns. 5x4, number of boys. How'd you know that? You're right. Yeah, it's boys or girls. And then if it's 5x, what's the number of girls then? That's right. Guys, is this important? Like the way they say boys and boys to girls? And so that 5 really goes with boys and the 4 goes with the girls. Is that important? Is that order important there? Yes? Okay, if it said girls to boys, then this would have been switched. Does that make sense? Okay, then what's the equation? Austin, what's the equation? What did you guys come up with? That's right, very good. So y is 5x plus 4x, guys, equal to 981. What sort of formula did we use here? Okay. What's the formula? This is a very easy formula, and very obvious. Maybe nobody really writes this formula down, but if you have boys and girls in the class, how do you find the total number of students in the class? You add them together. So here's the formula. Number of boys plus number of girls equals to total number of boys and girls. So, well, we just said 5x is number of boys, 4x for number of girls. You add them together, it should equal to 981, correct? Okay. And it is very obvious that it's not like 5 boys to 4 girls, right? Doesn't make any sense. All right, anybody need more, anybody need time to finish this up? Okay, we all got this? Yes? All right, then Rachel, are you guys done? Your group? Do you guys need more time? Is your group done? No? Okay, let me give you guys more time. Finish it up. Tell me what you get.
Oh my
Okay.
gosh, I'm done.
Is your group done?
You guys are done, right? Yeah.
All right, let's then go to Eddie. What did you guys do? What did your group come up with?
The answer,
Yeah, what did you get after this? So we came up with the equation, right? So when you solve for x, what did you guys get?
for boys we got 545, and for girls we got 436.
Okay, but when I solved this, did anybody get x? What's your value for x? when you solve for x here? Yes.
109.
You got 109? Okay.
We all got that.
Yes. What does 109 mean, by the way? Is that my answer, by the way? No, Eddie, you came up with something else. How did you get the answer from this?
We multiplied, then it's like x, so it's like 5x, so we multiplied it 109 by 5, and for girls, it's like 4x. We multiplied 109 by 4.
That's right. So, guys, do we have to plug this in to the 5x and 4x? Yeah, the x is not the answer, right? The x is the factor you need to multiply, right? These ratios to get the number of boys and girls. How many groups, raise your hand, got 549 for boys and
We got 545.
545 for boys and 436 for girls? Raise your hand. Okay. All the groups did? Yes? Any questions? Is this easy or hard? Easy? You guys get the idea?
Yes.
All right, then. Let's try next one. Okay, if you got that one, try this now. Guys, do we always have to... Hello. Guys,
You got
do we always have to compare two things together? No. This time we're comparing three people here, okay? Write this down. The height of three brothers are in the ratio of 13, 14, 15. Their combined height equals to 210 inches. Find the heights of each brother. Okay, go ahead. By the way, does this mean that their height is 13 inches, 14, and 15 inches? No. Okay, doesn't it add up to 210, does it? Go ahead, write it down.
Don't make fun of midgets.
Here we go. Chris, what did you guys come up with? How did you declare your variable? Shh, listen, guys. Huh? Uh-huh. Yep. Yep. Okay, guys. Can you repeat what Chris is right? Can you repeat what he just said here? No. Okay, Chemi, what did you just say? What did he just say? Oh, maybe we should be quiet and listen, right?
No,
Okay.
he's just really quiet.
No, I think, okay, Chemi, what did you guys come up with then? How did you guys declare the variable? Yeah, that's exactly what he said. Okay, so there you go. Now, who could come up with the equation? What's the equation for this? How about, yes, go ahead. That's right. How do we get the total number of heights? You add them all together, right? So you get 13x plus equals to 210. Then, Viviana, what did you get? X equals to? 5. How many people got 5? How many groups? Because you get 42x, right? Equals to 210, 5. Very good. Is 5 the answer to this question? No, please do not give me 5 as the answer. That's the number you need to multiply to each of these brothers, right? The ratio. So, it's called scale factor. What's the answer here then? Who haven't I called? How about Alvin?
What? The answer, it's 65 and 70 and 75.
How many people got 65, 70, and 75 inches? Good. Any questions? Will you be able to do something like this for your homework tonight?
Yeah.
No? Okay, good. All right.
I don't like